We'll go ahead and get started. I'm Heidi Anderson. I'm a recitation leader and the assistant for the Aggie Math Learning Center.
I'm Carly Princeton, also recitation leader for 0995.
So this is the Math 0995 CBE 4 review. Whoops. Right, stuff that this is going to go over is it covers lessons 20 to 26. We're going to go over sets and notation for sets, solutions of equations and properties of equalities, solving linear equations, solving absolute value equations, solving equations using the zero factor property, solving rational equations, and solving equations with radical terms. Lots of solving equations. Okay, so let's talk about sets and notations for sets. This interval notation first. So whenever we have these often called soft brackets, these parentheses, that means whatever number is next to that soft bracket is not included. So everything up to that point, but not including it. And we denote this with an open circle. That means in this one, it starts at 2, but it doesn't include 2. So in this one, we have a 2 as our upper bound there. If we have a square bracket, sometimes people call this a hard bracket, that means that number is included. Example here is this 3. Since this circle is a closed circle, we start at 3 and we are including that number 3. So we're writing our intervals starting with the lowest number and ending with the greatest number, connecting the intervals with a U, capital U, stands for union. So for example, in this one, that 2 is the greater number. Smaller number, it goes on for negative infinity numbers. With anything infinity, it's going to be a soft bracket. Then U to include this other one. Because it's a 3, it'll be a hard bracket. No, because it's a closed circle, it's a hard bracket. And we're going to all numbers bigger, the soft bracket. So let's try an example, this one. Describe the set of all real numbers that are greater than or equal to 3 and less than or equal to 18 using the interval notation. So we want some numbers that are greater than or equal to 3 and less than or equal to 18. I'm just going to write it with those greater than, less than signs because sometimes it's helpful for me to think about it. So if we have a greater than or equal to, will we be using a hard or soft bracket?
A hard bracket.
So this means we're going to be including that 3, we'll be using that square bracket. And same thing on this other side. This is less than or equal to, will we be using that soft parenthesis or that hard square bracket?
Hard square.
So not even looking at the numbers, just looking at that greater than or equal to, less than or equal to, we know that we're going to have 2 square brackets. So we want numbers starting at 3, between 3 and 18, including those, so we're going to use those square brackets. Does that make sense how I built up that notation? Sweet. 3, 18. All right.
Okay, now we're gonna start our never-ending equation solving. So we're gonna look at solving linear equations. So a solution to a linear equation is any value of x that makes the equation true. Linear equations are equations where the variable is only to the first power. So we would have x, right? And then there's a 1 here, but we don't write that. Linear equations usually have one solution, but they may have no solutions or infinitely many solutions. So they can have at most is one solution. We find the solutions by unpeeling or undoing what is happening to the variable. We need to make equality. So what you do to one side, you have to do to the other. That's kind of a fun, not fun, but a special property of equations, right? Versus expressions that we can manipulate them, but we have to multiply the same thing by both sides. Whereas expressions, we can only multiply by something that's equivalent to 1. Do you guys remember that? Kind of get what I'm talking about, the difference between expressions and equations. So now with equations, we can multiply by anything. We just have to multiply both sides by it, and we can still maintain that equality. And then you can rewrite to get a variable is equal to a value. So we're trying to isolate our variables so we know what that variable equals in the context of the certain problem we're solving. Okay, let's do some practice. All right, solve the equation and write the solutions in exact form. Okay, what do you guys want to do first?
Well, I don't like fractions,
Yeah,
so can we multiply both sides by maybe 5?
yeah, sure.
Fractions.
That's totally an okay thing to do. So we're gonna multiply both sides by 5. Okay, so then we get 5 times 4 over 5x, and then we can divide out, because 5 divided by 5 is gonna be 1. Plus 3 times 5, which gives us 15, is equal to negative 2 times 5 over 5. 5 divided by 5 again, we can divide that out. There's x minus 9 times 5. Oh shoot. I'll just cross it out, is 40 minus 45. Okay, and then we can rewrite it. 4x plus 15 equals negative 2x minus 45. Okay, what do you want to do next?
We need to get on either side of the.
Right.
side
Perfect.
to 0.
Yeah, so we're trying to set it equal to 0 so that we can solve. Well, in this, we don't necessarily have to set it equal for 0. You're a little bit ahead for the 0 factor property. When we have like two things that are factoring, that will really help us when x is not to the first power. So we won't necessarily need to set it to equal 0 here, but that is a great thought.
You just say have 45.
Yeah, so we can just add 45 to both sides, get those both on the same side, right? And then we can subtract the 4x to get those on the same side. Does that make sense how I did that? So that gives us negative 6x. Okay, and then we want to get the x alone, right? How could we get the x alone?
Divide by negative 6.
Right, right, because the opposite of multiplication is division. So if we're multiplying by negative 6, if we divide by negative 6, then we undo that. 6, so what's 60 divided by negative 6? Negative 10 equals x. Okay. X equals negative 10, perfect. And you're always very highly recommended on the CBE to plug your answers back in and make sure that they actually work. That's especially important when we start getting into roots, when we're taking the root, right? Because then we'll have extraneous solutions. Yeah.
When we're taking the CBE, are there questions that are asking just to solve for x?
There will be questions just asking for like a linear equation, just like this, where you won't have to use the 0 factor property or anything else like that.
So when you plug it back in, what are you looking for? Like
Just that we can do that right now. So 4/5 times negative 10 plus we're looking that it keeps the equation true. Okay, so that would give us negative 40 over 5 plus 3 is equal to positive 20 over 5 minus 9. So negative 40 divided by 5 gives us negative 8 plus 3 is equal to 4 minus 9. Negative 8 plus 3 gives us negative 5. And 4 minus 9 also gives us negative 5. So we're looking to make sure that when we put that number in, the equation remains true. So if it had come out to 3 equals negative 5, well, that's not true. So that means that we messed up somewhere. So that's what you're looking for when you check the equation. Does that make sense?
Yeah.
Okay, perfect.
For
Right.
it to equal 0.
What?
Yeah. Sorry.
Does that make sense? So if we wanted to write like our solution set would be just like
Now let's do another one like this, slightly different. So we're still solving for the equation. So in this one, what should be our first step?
Distribute 3.
Yeah, I'm seeing parentheses here, a number next to them. Implies I should use the distributive property. We'll just distribute that 3 across. So 3 times 4x is 12x. 3 times negative 5 is negative 15. Plus 8 equals, then do the same over here. 5 times 3 is 15. 5 times negative 3x is negative 15x. Sweet. Now I'm seeing, got a like term here and here. We'll combine those two. Get 12x. And what's negative 15 plus 8? Yep, negative 7 equals 15 minus 15x. So now we're in a form that looks kind of similar to what we had here. We have an x on both sides of the equation and also a number next to it. So we simplified with that distributive property to get it to a type of problem we've seen before. So you can either want to move all of the x's to one side of the equation, all of the numbers to the other side of the equation. So do you guys want to move the x's to the left or right? Either will work, it's personal preference. So want the x's. So if we want to move the x's to the left, I'll add 15x here. So because it's subtraction, we're going to add it, do that inverse. Add it over here. So 12x plus 15x is 27x minus 7 equals 15. Because we moved those x's over, we'll move this one over, that inverse operation again. We have 27x equals 15 plus 7, which is 23, 22. Thank you, 22. Now how do we get x by itself?
Divided by 27.
Yep, because it's multiplication, we'll do that inverse operation. We'll divide by 27. So x equals 22 over 27. If we plug that back into our equation, it would work. We'd have a true statement. Sweet. Any questions about this type of thing? Sweet. Okay, so solving absolute value equations. So we're going to talk about the definition of absolute value and how to solve absolute value equations. So absolute value gives us the distance away from 0. So an absolute value is negative, never negative, since we're talking about distance. So this applies to the entire expression, like this. It applies to the 5x plus 3, not individually. So we're first going to find solutions by isolating the absolute value. If we've got any like terms, we'll combine it. Remember, absolute values cannot evaluate to a negative. If the absolute value is said to be equal to a negative, that can't be the case, so we'll have no solutions. We'll see an example of that. Then we'll set up the two equations to find possible values of the variable that make the equation true. So we'll set the inside expression equal to the positive and negative situations. Okay, so problem 4, how many solutions are there to this given thing? So first, we want to isolate our absolute value. In this case, it's not already isolated. We've got this 9 here and we've got the 6 here. So if I have 6 times the absolute value of 7x plus 4 plus 9 equals 4. I want to get the absolute value by itself, so I'll move this 9 over. So now we have 6 times 7x plus 4 equals negative 5. To continue to get that absolute value by itself, is there anything still outside of our absolute value?
Yeah, you're 6.
Yep, the 6.
Multiply that on both sides, right?
Yep, we'll divide by 6.
I'll divide.
I mean, we could multiply by 1 over 6. That'd work.
That'd work.
Yep, but that inverse operation. So now we have 7x plus 4 equals negative 5/6. Okay. Can an absolute value ever give us a negative number?
No.
Nope. If I plug any x in here, it's going to give me out a positive number. Even if I plugged in negative 1, so that'd be negative 7 plus 4, which is negative 5, in the absolute value, negative 5, since it's distance from 0, we're still 5 away from 0, 5 units away. So there's no way this can happen. No way our absolute value is negative. Simply can't happen. Yeah.
What do they want on the test? They want D and E or they want no solution?
It'll usually
know?
tell you, like on homeworks and stuff, it'll say, if undefined, write this or something.
The practice test has like multiple choice,
Oh, okay.
because they probably don't want like people.
Wait, you're
doing
saying-
different things.
What have you taken CBE?
Well, no, I'm just saying the practice CBE for CBE 4 to practice. has like no solution, or it gives you like 3 things to pick.
It'll probably be multiple choice, or if there is no solution, write this.
Yeah,
Is there a way to, if we, or is there another problem of this?
Yeah.
Where we're, okay, sweet. Then
We'll
I'll
do an
say
example
my question.
where that it will have solutions, but in this case, there's no solutions. There's no way we can have an absolute value be equivalent to something that's negative. It's not how absolute values work. Any questions about that?
Sweet. Okay. How would you guys start this problem?
Subtract the 10.
Yeah, so in order to undo subtraction, we'll add it. So that gives us 3 times the absolute value. And remember, that's 3 is timesing, right? That's not adding, it's timesing by the absolute value. 4x plus 5 is equal to 12. And then what would you do from there,
Divide the 3 on both
Yes.
sides.
right? We're timesing by 3, so in order to undo that, we divide. Perfect. So it's 4x, the absolute value of 4x plus 5 is equal to 4. And then from here, okay, so here's where we gotta do a little bit of thinking, right? So we want something that when we plug it into this absolute value, we plug it in as an x in our absolute value equation, it'll give us 4. But there are 2 things that will be true for, right? If our value in this absolute value comes out to be equal to 4, then the absolute value of 4 is 4, right? But also, if whatever that value inside of there comes out to be -4, the absolute value of -4 is 4 as well, right? So we're going to be solving for those 2 equations. So how would I set those up?
one is -4 and one is 4.
Yes, so I'm trying to solve for what quantity would make 4x plus 5 equal to -4. And I'm also solving for what quantity would make 4x plus 5 equal to +4. Okay. So how would I start doing these equations? Let's start with the -4.
Subtract that one.
Yep.
I mean, yeah, same thing.
I got what you meant. And then from there, what would you do?
Oh, sorry.
Oh, that's okay.
Well, you divide by the 4.
Perfect. So it gives x is equal to -9/4. Okay, and this one will follow some similar structure, right? We'll subtract the 5 over. Gives us 4x is equal to -1, and then we'll divide by 4 again. And that gives us x is equal to -1/4. So our solution set for this problem would be -9/4, -1/4, right? Because if we plug those 2 solutions into as our x, it will give us either 4 or -4, and the absolute value of both those values would make this equation true. Does anyone have any questions about that? Or what your question was before? Do you still have the question?
Oh, kind of.
Okay, what is
Can,
it?
we can just check by plugging it back in, right?
So if you plug these answers back in, it's not really that hard to do it. So I'll plug it in really quick, but that gives us 4 times -9 gives us -36 divided by 4 would give us -9, right? Plus 5 equal to 4. And then we have the absolute value of -4 is equal to 4. And when we use the absolute value operator on -4, that pops out a 4, which gives us 4 equals 4, which is true, right? And if we have 4 times -1/4 plus 5 equals 4, then 4 times -1 gives us -4 divided by 4 gives us a -1 plus 5 equals 4, and that gives us 4. Absolute value of 4 equals 4. And if we use our absolute value operator on 4, that gives us 4 equals 4. So that is also true.
Okay.
Does that make sense?
Yeah.
So we just solve for the values that would make this equation true, but with an absolute value, there are going to be 2. If it's positive, there are going to be 2 numbers that make it true.
It's nice when you can double, triple check problems.
Yeah.
Okay. Sweet.
I'm writing over the solution.
Now we'll talk about solving equations with 0 factor property. Okay, So any number multiplied by 0 is 0. If we have 1 multiplied by 0, that's 0. 10,000 multiplied by 0, that's 0. No matter how big or small, anything multiplied by 0, that's 0. If the product of 2 or more numbers is equal to 0, then at least one of the numbers must be equal to 0. So if we have, say, some x, which is some number, and some y, that's some other number, equals 0. Well, if we had 0 times y, that's 0, or x times 0, that's 0. So either x or y, or both, I suppose, has to be 0. So that's our basis of our 0 factor property. So solving with that 0 factor property, first we want to get all the numbers onto one side so everything is equal to 0. So some numbers equals 0. We want everything on one side. If you like the left side, move it all to the left side. If you prefer the right side, move it all to the right side. Then we'll factor it. So it'll look something like maybe x plus or minus some number times x plus or minus some other number equals 0. So it's the same thing we were talking about before. Either this has to be 0, or this has to be 0, or both. So we'll set both of those things equal to 0. Our first one and our second one equal to 0 and solve it out. We'll set our second one equal to 0. We'll solve it out. So let's do an example of this. Okay, we're going to solve the equation and write the solution in exact form. So we're going to use that 0 factor property. So we want to move everything to one side. I'm going to move this one over to the other side because that's only one thing I have to move versus moving 2 things. So I'll do that inverse of negative 25. So I'll add 25x to both sides. So that's 5x squared plus 25x plus 30 equals 0. So that was my step 1. Move everything. Step 2, factor. All right, so what can we factor out of this? We could factor a 5 out of this, yeah. That'll make our next steps a little bit easier. So we factor out a 5 from 5, that leaves us with 1. So just x squared, factor out a 5 from 25, that's 5x. Factor out a 5 from 30, that leaves us with 6 equals 0. Okay, how else can I factor this?
Could, can't remember what it's called, but you know,
Yeah.
the two,
The AC method?
yeah,
Yep, so we want 2 numbers that add to whatever our a times c is. So remember that form is ax squared plus bx plus c. So in this case, we have 1 times 6, and those 2 numbers should multiply to whatever our b is, which is 5. So I have it flipped.
Should be 2 and 3.
Yes. So this one should be multiplied, right? There we go. 2 numbers that when multiplied. This is what I get for writing it in a different way. Probably seen, maybe you've seen the Xbox. Classic. So 2 numbers that multiply to a times c, and 2 numbers that add to b. So what 2 numbers fit this?
3, 2.
3 and 2. So now we can write it out this way. Factor it into, instead of 5x, can do 3x plus 2x plus 6. Now I can break that up. So we have 5. Can pull an x out of here, so that's x plus 3. And out of this second part here, I can pull out a 2. That's x plus 3. That's 5 times x plus 3 times x plus 2. Any questions on how I got there? These steps I lost you at? All right. So we've got this equation equal to 0. That means we need to use our zero factor property. So what will I set equal to 0? I mean, I could get rid of this 5 by dividing both sides by 5. 0 divided by 5 is still 0. So we have this x plus 3, x plus 2 equals 0. So if this section right here was equal to 0, then it wouldn't matter what's in here, because 0 times anything is still 0. And same the other way, if whatever's in here is equal to 0, doesn't matter what's in here, because 0 times whatever else is equal to 0. So we'll set this x plus 3 equal to 0. We'll set this x plus 2 equal to 0. Because if any of those two things happen, then this equation will be true. So solving x plus 3 equals 0, what does x equal? -3. And same over here. We'll subtract 2 on both sides, x equals -2. So our solution is going to be x equals -3 or -2. If we plug this back into our equation, we should get something that is true. You can try it. I'll try it up here. We have 5 times, we'll try -2 first. 2 squared plus 30. So wherever there's an x, we'll plug in this -2 equals -25 times -2. So what's -2 squared? +4. So 4 times 5 is 20. 20 plus 30 equals, and what's -25 times -2? +50. So 20 plus 30 is 50. 50 equals 50. Sweet. So we double checked that -2. We're good. And we can do the same with our -3. Let's try that. Just in case, because why not? So we'll plug in that -3. And what's -3 squared? +9, and 9 times 5 is 45. 45 is 30, and what's -25 times -3? 75. 45 times 30 is 75, so we got 75 equals 75. Is that a true statement? Sweet. So we double checked both of those solutions work. Yeah.
So would you get a right answer every time if you just factored, say, the x squared plus 3, the x squared plus 5x plus 6? If you just factored those into the.
Yep. Just going straight to here.
Yeah, factoring by grouping. If you just do that, is that like viable? Is that?
Yep.
Just triple check and I'll get there.
Lots of ways to factor.
How do
Pick
you
whichever
know,
way works.
how do you know when to use the zero factor property versus the other ways?
So in this other way, I go back. This one, we always have x equals some number, right? In this one, x, the highest power is 1, right? So we can always combine these x's. Over here, over here, we have an x to the power of 1 and an x squared.
So that's the key to
That's the key.
Oh.
If we've got mixes of those powers, if I've got an x squared and an x, you're going to be using the zero factor property. If it's just x's and you can combine them, set it equal to a number, then you can solve for x. If you've got multiple x's, we're going to have to factor and set it equal to 0. Good question.
Even like higher order too, like anything past just x to the first power. Rational equations. So rational equations are big fraction problems. Usually start by adding the fractions, usually begin by adding the fractions, making a common denominator is needed. Then we multiply the least common multiple of the denominators on each side. So we are left with a linear equation. Then you solve the remaining equation. Plug your solutions into the original equation to make sure they're valid. So these, we can start to get into some extraneous solutions. Do you remember the case that makes it extraneous when we have fractions? What can our denominator not equal?
So,
0.
0, yes. So if a number would make our denominator 0, it makes it extraneous. So even if we solve it all out and it comes out to that number, it's still extraneous, because if we plug it back into our original equation, it would make the denominator 0 and therefore would make the answer undefined. Okay, let's do some practice. All right. How would you guys start this problem?
distribute.
Sure. 3x minus 18 is equal over 3 is equal to 3x plus 3 over 8. Okay, then what should we do next? Should we try getting rid of the denominator? All right, so we're gonna find our least common denominator, so the least common multiple between 3 and 8. Do you guys have a preferred strategy of doing that? Do you want to do factor trees?
It's 24.
Well, it's 24, but
Uh,
if we factor tree out 8, right? 4 and 2, and then 2 and 2, right? Oh, don't look at that. 2 and 2, and then 3 is just 3 and 1, right? So 8, we have 2 times 2 times 2, so that's the prime factorization of 8, and then 3, the prime factorization is just 3. So we don't have any like smaller factors in common. So the least common multiple between 3 and 8 is 24. So multiply everything by 24. And then we can kind of cancel out how many we'll have to multiply it by in the end, right? So I'm gonna do it like that so I can kind of keep track of how much, but I'm multiplying both sides by 24. Do we see that?
Mhm.
Okay. So how many factors of 3 do I have in 24?
8.
Yes. So it becomes like that. Did I lose anybody there? Does that make sense that I can? Okay, so I have 24 divided by 3. Let me rewrite it out actually. So I have 24 times 3x minus 18 all over 3. So since everything is a factor, 24 can be rewritten as 8 times 3. So then I have 3 divided by 8 times 3, but then I have 3 divided by 3, right? Do you see that there's a 3 divided by 3 there? And so those divide out to be 1. Did that make sense? More sense? Okay. And so the other side will give us 3x plus 3 times 24 over 8, which again, 24 can be rewritten as 8 times 3. And then 8 divided by 8. So we have a factor of 8 on the top and a factor of 8 on the bottom. And everything is all factors, right? So then we can divide 8 and 8 out, and that's 1. Does that make sense? So that's how we can like cancel. We're just dividing them out, and them divided by each other is 1. Okay, so then we can rewrite this up here as 8 times 3x minus 18 is equal to 3 times 3x plus 3. All right, and then what should we do?
Distribute.
Right, then we'll distribute. Some of the algebra is going to get kind of wonky, I think, but all right, so you get 24x, and then 18 times 8 is 144.
Yeah.
Perfect. It's equal to 9x plus 9, right? That's how we distribute. And then we're going to combine like terms, right? So to do that, how would you start?
Subtract 9x.
Yes, perfect. So 24x minus 9x will give us 15x minus 144 is equal to 9. And then we'll add 144 to both sides. And that gives us 15x is equal to 153. And then from there, we'll divide by 15, right? To undo that multiplication.
Check that. Let's see. 18, 3.
Oh wait, just kidding. I'm looking at the wrong one on my iPad. Okay, sorry, team. All right. Now what do we do? Do we know that this is all the way simplified?
No.
Okay, so how are we gonna figure out if it's all the way simplified?
Well, the factor's 15 or 5 and 3.
Yeah, factor 3.
Then there's a 3 and the 153, so it can be simplified.
Yeah, so 153 divided by 3 would give us 551. So we could split 153 into 51. So we have a factor of 3 here, and 15 can also be split into 5 and 3. So we can rewrite this as 51 times 3 divided by 5 times 3, and 3 divided by 3 is 1. So then our x is equal to 51 over 5. Does that make sense, everyone? I'm not gonna plug that back in because, yeah, but on the CBE, you probably won't get a number as bad as that, but but yeah, so. Does anyone have any questions? We'll do an example again of a similar one.
Right. Let's try another one. Again, we're gonna solve this equation, write the solution in an exact form. So these all have different denominators. We want to get them all to have the same denominator. So got a 2, got an x, and I've got an 18. So is there any common terms in here?
No.
Not really. I mean, I can factor 18 into 2 and 9. So I mean, I could multiply this 2 by a 9 to get 18. But still, they're not all the same. So I could multiply this x by 18 and get 18x. So now we've got an 18 and 18x and another 18. So what can I do to these first two to make it look like this middle one? I think we could multiply by an x, right? Why not? You could multiply that by an x. So to change this one, I'm just going to multiply both the numerator and the denominator by x. It's important that you multiply both because what's 5 divided by 5? It's 1. So what's x divided by x? That's 1. I like to call this 1 in parentheses. It's 1 where we're not changing the equation, but we're modifying it to be something that's a little bit easier to work with. So on this one, we'll multiply the denominator and the numerator by 18. On this one, we'll multiply, we modified it with a 9 and an x. So multiply it by 9x. So we get 3 times 9x over 18x plus 12 times 18 over 18x plus 5 times x over 18x. And I suppose we can get this one to also be in this fraction. How can we make one have the same denominator? We'll multiply it by all three, 18x over 18x. So that's just multiplying by 1. 1 times 1 is still 1, but now we can have it equal this 18x over 18x. Any questions as to how I got to this point? Sweet.
And this is like the way to solve it by getting a common denominator, and the previous problem we solved it with the way to get rid of the denominators when you start out. So this is just a different strategy.
Yep. So what's 3 times 9x? 27x. My 9's tables aren't as good as my other tables. And what's 12 times 18? I think it's 216. Okay, plus 5x. This is all over 18x equals 18x over 18x. Okay, Well, this is like our other one, where now we've got something over a fraction. And this one, we multiplied to get rid of the fraction, right? Could we do the same thing here? What could we multiply by to get rid of that 18x in our denominator? I have an 18x, the denominator. If I multiply by 18x here, this would go away, right? But what I do to one side, I've got to do to the other side. Sometimes I like to put it over 1. Or I can see goes way like that. Okay, so now we have 27x plus 216 plus 5x equals 18x. And I'll point out in this one, are all of our x's, do they have the same power? We've got just x to the power of 1, right? We don't have like an x and an x squared. That means we don't have to use the zero factor property. We can just solve for x. So we'll combine this 27 and 5, that's 32x plus 216 equals 18x. And then we'll move this 32x over by subtracting. So what is 18x minus 32? Looks like negative 14x, unless I did algebra wrong. Okay, then we can get x by itself by dividing by that negative 14. And we can factor out a 7. 216, negative 216, we can factor that into 108, 7. Or positive 108, negative 7, and we can factor out negative 14 into 2, negative 2. Wait, no, 2 and 108, sorry. My brain, 2 and 7. So we can simplify this to negative 108 over 7. This is positive. Goodness. Any questions along the way of this? Sweet. And if we plugged this value back into here, we would get a true statement. So for this one, get a like denominator, and then you can get rid of that like denominator and solve for x.
Okay. Okay, this one, I'm gonna do, again, a little bit of a different strategy than Heidi. But they all work the same way. This one, I think, makes it simpler for me, but it's gonna have different ways to represent things. Okay, so let's find our least common denominator. But first we're gonna have to factor this. So let's put that over here. All right, x squared minus 3x plus 2. How would we factor that? What adds to be negative 3 but multiplies to be positive 2? X minus 1 and x minus 2, right? Okay, so our factors that we have from our first fraction, our factor is x minus 2, right? From our second fraction, our factors we just factored, we have x minus 1 and x minus 2. From our third fraction, our factors is x minus 1. So what would our least common denominator be to account for all the factors in each of our denominators?
X minus 1, x minus 2.
Right, so we only have one x minus 2 in this one and one x minus 1 in this one, so that way, therefore, they're both accounted for because we have one here and here. So we had x minus 2 squared in the first one, we would have to multiply it by another x minus 2, but since we only have one in each of those denominators, they're accounted for. So x minus 1, x minus 2 is our least common denominator. All right, so now I'm gonna rewrite it so we can multiply everything by our least common denominator. So I'm multiplying everything by the same thing, and therefore I can multiply by this thing. Okay. So the first one, what can I divide out?
X minus two.
Yeah, so I have x minus 2 over x minus 2. And x minus 2 divided by x minus 2 is just 1, so we can cancel those out. All right, and then what about for the second fraction?
You gotta distribute it.
So I don't have to distribute. They're all multiplying out, so I know that x minus 1 times x minus 2 is the same as x minus 1 times x minus 2. So in that way, I just have 1. I can divide them both by each other, and since they're the same, I just have 1. So I can actually just cancel those both out. All right, and then what about the term on the right side of our equal sign?
You can cancel the X minus one.
Yeah, so x minus 1 divided by x minus 1 is 1, so we can cancel that one out. Okay, now we'll rewrite it. So 2 times x minus 1 minus 4 is equal to 5 times x minus 2. And also important thing to note, remember our denominator, what can't our denominator equal? What will give us 0 if our denominator is equal to it?
0.
Well, 0, so what number, if we plugged it into our original equation, would give us 0 in the denominator?
Oh, like a +2.
Yes,
or a
yes.
+1.
Yes. Oh, whoops, I should have done that in order. So that's something to keep in note, right? So if we get 1 or 2, then those would be extraneous solutions. Okay. All right, now here, what would we do?
I distribute.
So we get 2x minus 2 minus 4 is equal to 5x minus 10. And then we'll combine like terms, gives us 2x minus 6 equal to 5x minus 10. And then we'll continue to combine like terms and rewrite it up here so we have a little bit more space. So I'm going to move the 2x over to the right side of the equation. That way I won't go negative, but it doesn't matter. I could have subtracted the 5x from the 2x and it would have worked out the same. So that gives me -6 is equal to 3x minus 10. And then what would you do to isolate the x from there?
You subtract the 10. We can add the 10.
Yeah. So we're trying to get the x by itself, so we'll add the 10. Gives us 4 equals 3x. And then from there, how would I undo that multiplication 3 times x? So I can get x by itself.
Oh, yeah, by the terms.
Right, so I'll divide by 3, because 3 divided by 3 is 1, right? So then we only have 1x, so that gives us 4/3 is equal to x. And then once again, we could definitely plug that in and check for that. So that's kind of the general strategy. That's my preferred strategy, is to get rid of the denominators first thing off. I don't really like to work with them. I don't want to find a common denominator, but that's also a really, honestly, like if you're having trouble figuring out what to cancel out, then when you find a common denominator, right, you're just canceling everything out, right? So just kind of depends on how your brain works best. So I complement each other so well.
Cover it all. Okay, last section is solving radical equations. So we're going to talk about what is a radical equation and how we're going to solve them. So radical equations are equations that have a root in them. For example, see this a lot. This is a square root. Don't know if you'll see, do they see other roots other than square roots?
Yes, but not solving equations typically.
Okay. So you may have seen a cube root.
Remember when
can
you had
have
to do all that
any
like
number.
simplifying with like crazy
Mhm.
roots?
So remember, if there's nothing there, we assume that it's a 2. So solving equations that have those roots in them. So to solve these, we're going to start by isolating the radical. So wherever the radical is, we're going to have it be by itself on one side of the equations. We're going to undo the radical with exponents. Remember that if we have like a square root of x, if we square it, raise it to the power of 2, then that gives us just x, kind of undoes it and undoes it in that way. Then we'll solve the remaining equation. We'll check our answers. Sometimes when we're squaring, we're introducing other solutions that aren't true. So for these ones, it's not optional to check your solutions. You need to check the solutions every time. So the other one, it's like, oh, it's a nice double check. This one, we risk getting something that isn't true with the squaring. So let's try this. Okay, so we want to get a radical on one side of the equation. So I'll move the x over. So now we have negative square root of 2x plus 4 equals -2 minus x. I've still got this negative here. We can think of it as a -1. Still want to get radical by itself. We'll divide by -1 to make it positive. And what's -2 divided by -1?
-2.
It'll be a +2. If we have a negative number divided by a negative number,
Oh,
that's a
negative.
positive. Yep. So that'll be +2. And will the x be negative or positive?
Positive.
Positive, because we've got minus and a minus. Okay, so now we've got the square root of 2x plus 4 equals 2 plus x. So we've isolated our root. Now, second step, we want to undo. So how are we going to undo this square root?
Square both sides.
We'll square both sides. So when we square that root, we'll be left with just what's on the inside. So that's 2x plus 4 equals, and we've got 2 plus x squared. So with this, I like to write it out like this sometimes, because you don't want to just bring that 2 in. We've got this sort of thing happening. So 2 times 2 is 4 plus 2x. Same over here. We've got plus 2x plus x squared. So this is x squared plus 4x plus 4. Common mistake I see sometimes is people just bring this 2 in and say, oh, it's the same as 2 squared plus x squared. So that's x squared plus 4. These two things are not the same thing. Be sure that when we're squaring those expressions, you're actually expanding it all the way. Don't just bring the 2 in. That's not how exponents work. Be careful. Gets me to this day. Okay, we've got x squared plus 4x plus 4. Okay, see, we've got this mix of x squareds and x's to the first power. That means we're going to be using the zero product rule. So we'll bring this 4 over, and we'll bring this 2x over. So we've got 0 equals x squared plus 2x. Okay, now with this zero factor property, we've gotten everything on one side with a 0. Now we're going to factor that. So what can we factor out of this?
X.
We can factor in x. X plus 2. I'm going to erase this over here, just so I have some more work. So now we have either x can equal 0 and x plus 2 equals 0. So x equals either 0 or -2. Now let's double check those. Our last step. Check with an exclamation mark. Okay, let's check 0. So 0 minus square root of 2 times 0 plus 4 equals -2. So this is negative square root of 4 equals -2. And what's the square root of 4? 2. Does -2 equal -2? Sweet. So we've checked 0 as one of our solutions that does work. Now we've got to check that -2. So -2 minus the square root of 2 times -2 plus 4 equals -2. So that's -2 minus the square root of -4 plus 4 equals -2. So that's 0 in there. That's -2 minus the square root of 0. -2 equals -2. Sweet. So we've double checked -2 also is a good solution. So be sure you're always checking those. In this case, both of them worked out, but you're not guaranteed that. So, yep, that's everything for the CBE review. We've got other resources on the Aggie Math Learning Center website, as well as the tutors. If you have any questions, let us know. Thanks for coming.